This episode of The Climate Show is brought to you by Celsius.co.nz, HotTopic.co.nz, SkepticalScience.com, and Kiwi FM.
What good is a drop in the ocean? What good is a drop in the ocean?
Well, hello and welcome along to The Climate Show. This is episode number 6, recording on, the 2nd of February 2011. Thanks for watching, thanks for listening, or however you digest this show. What is it? It's a show about climate change, climate news, climate science, climate issues, climate skeptics, and also truffelators as well, because that's what Mr. Gareth Ronaldon, I think, is. Can we call you a truffinator or a
No. Je suis trufficulteur.
Hello, Gareth, at Hot Topic, joining us from Limestone Hills. How you doing?
Being blown away today. We have one of those wonderful North Canterbury nor'westers. It's about 32 degrees Celsius at a guess, and blowing a gale, and my trees are being shredded, and my eyes are gritty, and no doubt I'll have a headache long before I've even had a glass of wine to make a change. But so it's a hot day, hot and dusty.
Yeah, and the reason why I was talking about truffles, the reason why I was thinking about that, because I was browsing around, because you've got a few websites, a few feathers to your bow, and I'd seen that you've written books on truffles. In fact, the guidebook to finding truffles in New Zealand, which I thought was extraordinary. These things I just didn't know about you, Gareth.
Yes, well, you see, truffles were what I did when I first came to New Zealand, and you could describe them as my first love, because I'm a foodie, you see, and truffles are one of the pinnacles of French cuisine and Italian cuisine. So, yeah, I just like to grow my own.
Truffulator by night or truffulator by day?
By day mainly. If you go out at night in France looking for truffles, you tend to get shot. Right. Because it's only poachers that do that. So no, we're very polite, and we have a little dog that we take out to find our truffles. Oh, cool. But interesting, there's even a potential carbon angle there. It's a very low sort of carbon crop, because what we're doing is growing trees, and the amount of crop we take out of the ground every year is measured in a few kilograms, and the trees are fixing a lot of carbon. So I actually think that I can harvest a truffle, ship it to London by air freight, and have it arrive on a restaurant table in London and still be carbon negative. Well, there you go. A crop for the future.
Yeah, absolutely. Okay, well, so there's the link, because of course we're here for climate change. That's what we're talking about, from truffles to climate change, and the home for the show, of course, is at hot-topic.co.nz. Very soon to be, I promise, because I've been tinkering around this week at theclimateshow.com as well. We'll have a brand new website where you can go and discuss some of the issues we talk about over there as well. And we
Absolutely. It's a very cool blue colour too. So.
Yes. If you've watched the video of the show and you've seen the intro, it's kind of a little bit like that. There's a theme going on there anyway. But we've got a great show lined up. Of course, we'll be covering some of the latest news, and there's a bit of that about at the moment. Also, our special guest is Dr. Philip Boyd. We're looking at phytoplankton, or fertilising the seas, as it were, as a solution perhaps to climate change.
Yes, Philip's one of the co-authors on a just-released report. I think it was actually released on Monday, talking about ocean fertilisation as a possible way of removing carbon from the atmosphere. So we'll be talking to Philip about that. He's one of the leading experts in the field, so that's a real privilege for us.
And also, I've just finished watching a BBC documentary that hopefully many people around the world will be able to get to see. It's called Meet the Skeptics. And one of the skeptics in the documentary, in fact, the central figure, is a guy called Christopher Monckton. You might have heard of him, Gareth.
He just as it happens, I've been blogging about Viscount Monckton of Brenchley for a number of years now, and I've even been writing parodies of the activities of Viscount Monckton of Brenchley. So it's a very great pleasure for me to announce that this is the Climate Show's Monckton special, and we've got John Cook of Skeptical Science, who has been devoting, and the Skeptical Science team has devoted a considerable amount of time and effort to developing a section of the site called Monckton Myths. And this is your one-stop shop for debunking Monckton. So we'll be talking to John about that a little later on, and I'm really looking forward to that. And
hopefully it's work like John's at skepticalscience.com, which will mean that we won't have to cover this kind of stuff so much in the future either. Because I somewhat find it, I mean, it's interesting, but it's a little bit distracting from the central issue of climate change and how the heck are we going to dig ourselves out of this mess. But at the moment it is still important, while he's still getting coverage in the mainstream media, that we do need to talk about this guy and others like him as well.
Absolutely. The whole point, and what John and Skeptical Science do so brilliantly, is that they make it easy to deal with ostensibly sensible arguments. So when someone like Monckton makes an argument and says we don't need to worry because, then you can find the answer why we do need to worry, the sort of rebuttal of his arguments in one place. And the great thing is that Monckton repeats himself a lot, so it's very easy. You can go through and follow the memes of skeptical thought. Yeah, so we cover that with John a little bit later on the show, and of course also some solutions at the end of the show. I think there's a very cool car that you want to talk about, Gareth. Yeah, it's a 1970s Datsun. Very, very cool car.
Okay, and just a reminder, if you're watching the video stream, you can listen to the audio, perhaps take it on the road with you, and you can also subscribe at iTunes. Search for The Climate Show on iTunes, or find it in the show notes up at hot-topic.co.nz, and vice versa as well. If you're listening to the audio, you might find the video quite exciting as well. And that is also available up there at hot-topic.co.nz, and soon theclimateshow.com. Let's get into the news, shall we?
Yes, absolutely. First up, I wanted to draw attention to a very interesting recent paper which investigated a sort of 2,000-year record of ocean temperatures in the North Atlantic. And Glenn, if you can get that diagram or the chart up on the blog, that would be good. What they did was they looked at a seafloor site off the coast of Svalbard. Svalbard is a group of islands to the north of Norway. What they did was they looked at a core off the coast of Svalbard, seabed core, and from the records in the core of the microorganisms, the phytoplankton and so on, that were growing in the ocean column, they were able to date those, and they're able to infer what the ocean temperature was at a given time. And what they've discovered is that the water that's currently entering the Arctic is warmer than at any time in the past 2,000 years, and that this could be one of the key things impacting the decline of Arctic sea ice. This is a paper in the journal Science, and it's interesting that the amount of water of this particular kind of water, it's the Atlantic warm layer, which is not quite at the surface, it's below the surface, but both the quantity and the temperature of this water going into the Arctic Ocean has increased and is running at record levels, at least record levels over 2,000 years. And what's interesting is that one of the leading experts on sea ice, and one of the guys who's made the most aggressive predictions for when we'll have ice-free summers or ice-free periods in the Arctic, is a scientist called Wisław Maslowski at the US, in the US, and he believes that the key to a lot of the reduction in sea ice over the last decade has been because of heat being shipped in by the oceans. And generally speaking, the climate models have not been terribly good at handling the flow of sort of modeling the oceans and the flow of heat in them. So here's a paper that confirms a number of suspicions that it's actually heat being shipped up from the south by the oceans that is having, or is at least a major part of, the reductions in sea ice that we're seeing up there.
So just looking at that diagram, ultimately, is that warmer water coming from the tropics? I mean, you say from the south, so therefore, I suppose, the tropics?
Yeah, absolutely. I mean, what's happening is that you've got the subtropical oceans down in the Gulf of Mexico and the tropical South Atlantic, and then you've got what's called the Gulf Stream, or the North Atlantic Drift, and that ships warm water on what they call a gyre, a sort of rotating whirlpool, if you like, that covers the whole North Atlantic. And some of that warm water then heads up north of Scandinavia and ultimately up around Svalbard. So the heat's coming from the tropics and is being shipped up north by the ocean currents. So what this study does is give us an idea on how those currents have changed over the last 2 millennia, and given us an interesting picture of what may be another hockey stick. And here's an area where warming is unprecedented in the recent past.
Okay, well,
so that's it. That's interesting. We've looked at the Arctic a number of times in these shows, and I'm sure we'll continue to do so. But this was an interesting paper, and I'll provide a link to the Discovery mag article about it, because the chart that Glenn's been showing comes from that, and it does show it really very clearly.
Yeah. All right. Well,
so the next thing.
Yeah. On to another piece of information from the internet that's come through. A nice infographic, which we really like. This one from, is it? Where is this one from? Actually, is it from?
It's from the Guardian.
Yeah, Guardian.
It's from
the
Guardian.
Yeah.
The Guardian has an excellent data blog where they go through and map the various data sets, and they've done this. I think this is the second time they've done this one. This is an atlas of carbon dioxide burning for 2009. That's the most recent year that we have full data from. And what they've done is they've mapped them up as so if you look at those coloured balls, you can see that they're sort of roughly laid out like an atlas. So the bright red big ball top left, that's the US, and then Canada's hanging off, and then Mexico's to the south, and then the orange stuff in the southern hemisphere is South America. Come over, there's brown dots, which is Africa, then there's the Middle East is yellow, and then you've got Australasia, or Asia and Oceania that they call it, and the big daddy there is China. Hanging off China, you've got India, which is growing rapidly, and then right down bottom right, you've got little old New Zealand hanging off the side of Australia.
So we still make a dot, which I think is quite amazing for such a tiny country. Yeah,
absolutely. I mean, we are a developed world nation. We do have very high per capita usage or emissions of CO2 from our energy use and transport fuels, and also from methane from agriculture. But these emissions are from energy use, so they don't include land use changes and those sorts of things. Right. And they actually show that in 2009, emissions from energy use actually declined very, very slightly. So if you look at the US, you can see that the number there has fallen. If you look at Europe, which are the sort of maroon dots in the middle there, virtually all of those show a decrease. Russia shows a decrease, but then you can look at very strong growth in China, to the point where China is significantly larger than the US in total. Strong growth in India. And I think what the figures are showing is that the economic recession cut back on carbon dioxide emissions in 2009, except in those countries where growth was largely unaffected, and that's China and India. So I wanted to include this graphic because I just thought it was a really good representation of the dynamics of the problems that we face with emissions, because you've got the big players. That's the US, that's China, that's India, that's Russia, that's the European Union, and those are the countries that are going to have to make really big strides in reducing emissions if we're to have any hope of avoiding the worst extremes of climate change. So I'd highly recommend a trip to that site and a nosy around. You can download the chart as a PDF. You could probably also print it out and stick it on your wall if you wanted. But excellent bit of data visualization, I thought.
I think it's an alternative to, for your wall, for maybe a child's wall, an alternative to a diorama or something like that.
Yeah, absolutely. You could do a mobile version of it too.
It's nice
over a pot.
It's nice and colourful and all. Yeah, why not? Hey, on to the final piece of news. It's easy to forget, of course, some of the devastating floods that happened last year, especially now with some of the stuff that's happening in Queensland with another cyclone bearing down on Queensland at the moment. But the Pakistan floods, which were very devastating, could have been predicted.
Yeah, it's really interesting. I don't want to preempt the conversation we're going to have with John later, but about a week ago, I looked at the predicted weather charts for Australia and New Zealand from the European Centre for Medium Range Weather Forecasting, ECMWF in the jargon, and they showed a very strong tropical cyclone heading for the coast of Australia. And as the weeks passed, I've seen that this has actually turned out to happen. So I was very impressed that this tropical cyclones are really hard to forecast, but this model picked up the details of the cyclone and got it more or less right at a range of 6 or 7 days, which is I think remarkable. Now what this new paper says is that 5 days before the intense rainfall hit Pakistan, the computer model at the ECMWF was actually showing record-breaking rainfall in the region. And if the information had been processed and made available, Pakistan could have had perhaps as much as 8 to 10 days warning that they were heading for some pretty extreme flooding. So what that means that you would have to have a flood model for Pakistan, which is basically what they use in Australia to say, how much water is, if you put this much rain at the top of the catchment, how much flooding are you going to get lower down? So you'd have to have a flood model for Pakistan. But then if you feed into that this sort of data from the computer models, you can get a prediction, and they could have been able to warn people about the flooding as it came downstream and perhaps manage to save some of the infrastructure or save lives and save some of the impacts, at least get people prepared. And the reason that interested me is not because he is a successful weather forecasting or anything else, but it's because this is the sort of thing that we're going to need a hell of a lot more of. We expect the extremes of rainfall and heat waves and so on to increase as the climate changes. There's more energy accumulating in the Earth's climate system. So what we need to do is find ways and means of predicting when these things are going to happen. So one range, we need the sort of 8 to 10 day forecasts of flooding and heat waves. And there are good signs, as this new paper suggests, that our current weather models are capable of coping with the sorts of changes that we're seeing. But with the next stage, and this is the next stage for climate modeling as a whole, is to look at how we can improve the climate models to provide us with useful regional long-term forecasts. So being able, at the moment, the climate models are giving us a global picture, and they're giving us hints of what the regional effects might be. But giving a reasonably accurate regional forecast is much harder than predicting a global average. And so that's something that the climate modelers are going to be working on very hard as they prepare for the 5th IPCC report, but also going forward from that, regional predictions. But I just thought this was an interesting paper because it proves that the current modelling of the atmosphere is able to cope with some extremes and could be used to help to reduce the impacts of these terrible events.
Right, yeah, and if policymakers and people who make decisions for communities can put some trust in these kind of models, then that's got to be good news all round, I think.
Absolutely, absolutely.
Right, well, very shortly we're going to get on our feature guest for the show, which is Dr. Philip Boyd, a phytoplankton ecologist. But first up, I do want to thank a couple of sites who are helping distribute the show, apart from Hot Topic and soon theclimateshow.com. Of course, it's scoop.co.nz, news site based in New Zealand, but providing really good coverage on international issues. In fact, they've been all over the Egypt situation over the past week or so. So go check them out at scoop.co.nz. You'll also find our show there. And Celsius.co.nz, which looks at sustainability and business in New Zealand being more community-minded, I suppose, as well. CELSIAS.co.nz. Thanks very much to those two sites for helping get the climate show out there. Rightio, this will be a pretty good time, I think, to get our feature guest in for this show, Dr. Philip Boyd, who is a phytoplankton ecologist whose research interests include the environmental control of phytoplankton processes, the ocean's iron biogeochemical cycle, and the biogeochemical coupling of surface ocean with deep water processes. I'm pretty sure he's going to explain what a few of those things are. But Dr. Philip Boyd joins us. Hello to you, Philip.
Hello.
Good afternoon, Philip. It's Gareth here. Yes, the reason that we invited you onto the show today, and many thanks for doing it at short notice, was the announcement this week of a new report on ocean fertilisation, on which you're a co-author. Could you tell us what the report's about and what it means for the world?
Yes. Before I tell you about the report, I'd probably best step back a little bit and explain what ocean fertilisation involves. Some parts of the ocean seem to do better than others. Some parts are more productive than other regions, and in particular some vast areas of the Southern Ocean, for example the waters south of New Zealand, aren't doing as well as they could or should, and that's because the mixture of nutrients and trace elements that they get is slightly incomplete. They don't have the full range of minerals and vitamins to grow as rapidly as they could, and thereby by amending the properties of the surface ocean, it might be possible to enhance their growth and thereby fertilize the ocean.
Do we know why the oceans down there are short of these key nutrients?
Yes, they have one particularly important element which is in short supply, and that's the trace element called iron. So it's a little bit like I use the example of anemia. In humans, if you're anemic, you're not quite yourself, you're not quite 100%. You usually have to go off to the doctor and get dosed up with some iron tablets, something like that.
Right.
And it's the same case.
So in other parts of the world's oceans that do have adequate amounts of iron, where's this coming from? Is it kind of blowing over the sea off the land, or as dust, or?
It comes from a number of different sources, and that's something that we're really just getting a handle on. We're trying to build some sort of budgets across the globe. But yes, as you mentioned, iron would be one of the main, iron from dust would be one of the main sort of supply mechanisms. And so, for example, we can see in places close to desert regions, such as the North Atlantic Ocean, close to the Sahara, they are inundated with these large dust storms. We can pick them up as a huge sort of muddy brown curtain from a satellite image, and they help in enriching those waters, and therefore ensuring that the microscopic plants get their full dietary complement of the trace element iron.
So as I understand it, there have been some experiments off the coast of New Zealand, adding iron to see what happens.
Yes, one of the big interests in iron is that if we go back into the geological past, and by that I mean sort of over the last sort of 200 to 300,000 years ago, we can see from some ice core records that there have been quite marked changes and departures in the concentration of carbon dioxide in the atmosphere, and at the same time, or possibly slightly before that, there have been also then changes in the amount of dust that's been blowing into this region. So that there's certainly been an interest with respect to finding out a little bit more about what drives global climate. I've been trying to ascertain that. That's really sort of the holy grail of climate science. And so one of the potential mechanisms that's been put forward is that long ago in the geological past, thousands of years ago, changes in the amount of iron supply may have naturally fertilized the ocean, and therefore that was something that we were particularly interested in. Of course,
sorry.
Sorry, I was going to go on to say then, but of course, the flip side to this interest in ocean fertilization is that with discussions occurring in the last couple of decades, but particularly in the last 5 years, there's been a growing interest in some sort of human manipulation of the planet, this so-called geoengineering. And the wide range of schemes in iron fertilization is one of those.
There was an American company, wasn't there, that was attempting to market carbon offsets from, or they started on a scheme to market carbon offsets from fertilizing the oceans, which I think it kind of fell through, didn't it?
Yeah, there have been a number of different companies. I think the company you're referring to is one called Planktos, who at one point managed to, through the connections, commandeer the Singer Neil Young's yacht and sort of gaily sail along in the central Pacific Ocean, sprinkling sort of iron salts over the side. So yeah, there have been a number of publicity stunts that have happened like that. We've also had another US company of geoengineers, one called Climos, who actually came down and visited both New Zealand and Australia, canvassed various government departments, went over to Nelson to see how many ships they could charter, and sort of did a bit of a recce really on New Zealand and Australia.
So were they onto something? You've been involved in experiments to try and find out, haven't you?
Yes, well, as I say, the experiments we've looked at are to do with sort of climate science and not geoengineering. However, what's happened of late is that the geoengineers have, of course, come through and sort of gone through the data, much of which is out there in the public domain, and they've been, shall I say, reasonably selective in choosing what they wish to believe or what they wish to publicize. What we have found from these experiments, and to give you some idea of the experiments, they're probably up to 1,000 square kilometers. That means you can actually see them from satellite, you can pick them up from space, in quite stark contrast to the sort of surrounding waters where the plant cells were still anemic. But suffice to say that from our experiments to date, surprise, surprise, it's always a little bit more complex than you think. And there's been a significant difference, obviously, between a scientific party of international researchers going out and trying to answer target questions and then trying to publish it in the peer-reviewed literature, and as I say, someone offer a bit of a jolly in Neil Young's yacht, putting some iron salts over the side of the ship and saying, oh yes, it looks like something happened.
So can you explain exactly how this process sequesters carbon?
Yes, what happened is in the upper ocean we have these microscopic plants, and the reason they're important is by virtue of the very large expanse of the ocean covering much of the planet. And estimates have shown that at least half of all of the carbon that's fixed by plants photosynthesizing happens in the ocean. So it's an important and very productive region of the planet. And in addition to supplying productivity that might then move up a food chain and ultimately fuel fisheries or something like that, the other part of the story is the amount of this phytoplankton or plant carbon that actually sinks into the ocean. So essentially what happens is in the lit part of the ocean where sunlight penetrates, these plants photosynthesize, they take up CO2, they fix carbon, and then a small but a significant amount of that carbon eventually runs a gauntlet of various other critters that want to try and eat it and graze on it, and actually sinks at speeds of up to a couple hundred meters a day down into the abyss. So essentially what it does is it takes a little bit of that carbon out of circulation away from a place in the ocean where it can actually communicate with the atmosphere. The next stage then is, because we've removed some of that CO2, some of that carbon dioxide from the upper ocean, is we have to balance the books, and therefore a certain amount of atmospheric carbon dioxide has to then be taken up into the surface ocean to give us an equilibrium again. And the flip side of that, of course, would be outgassing. So that's basically why your beer goes flat. Would be all of the CO2 in your beer, which is in excess to that in the atmosphere, eventually all just gases out into the ocean. Your beer goes flat, but it's really just gone back into equilibrium. And in the same way, if we're pulling carbon dioxide into the upper ocean, into this liquid, we have to pull some more carbon out of the atmosphere, and therefore we actually are running what's called a biological pump. We're using the ocean's biota to pump significant amounts of atmospheric carbon dioxide into the ocean.
And so does the sorry, Glenn, does the biological pump and this equilibration of carbon dioxide, does that have an impact on the acidification of the ocean?
It will have an impact on the acidification of the ocean, yes. But that's probably another issue, not to go into in this reasonably short slot that we have.
Okay.
I was just thinking that you were describing that process of pulling the carbon, down into the abyss. Now, as far as I understand the science, isn't that what happened millions and billions of years ago? And the oil that we are now using and burning up in our cars is actually produced from that method originally, from that natural method of all that carbon sinking to the abyss and then compressing and then eventually being the fossil fuels as we know them today.
No, that's correct. Yes, we're basically spending up big time on all of that carbon that was naturally sunk out into the deep ocean, as you say, formed sediments, and then under pressure formed hydrocarbons. Yeah,
and also I think, Gareth, you were just touching on that acidification. I mean, is there, and I know we don't want to go too far into that, but is there a potential for over-fertilization, creating too much biomass in the oceans?
Yes, a number of the spin-offs. One could be anoxia. That is that as you break down some of this material as it sinks, you need oxygen to do that. And as that's occurring, you could use up, in some cases, all of the oxygen, and you might end up with something akin to, you've heard of the dead zones off the Mississippi Delta, where there's such a huge runoff of agricultural fertilizers in solution that they have huge blooms, and then they end up with just this dead zone with no oxygen in the water. And similarly, if you're going to be using up the oxygen to break down these components, you're going to be releasing some CO2. So some work by mathematical modelers have suggested that, you could actually make the deep ocean more acidic if you were to conduct some of these schemes, which is just one example of, again, things being more complex than we thought. And there are so many interconnected processes in the ocean that simply going out to geoengineer it by adding iron or some of the nutrient, it really is a very sort of simplistic view.
So what's the conclusion of the report on which you're a co-author?
The conclusion of the report, or rather, let me just step back. The report attempts to do a number of things. Up until fairly recently, any discussion about geoengineering, what we call the ocean commons beyond the sort of territorial limit, has existed in a policy vacuum. There hasn't been any policy or any regulatory legislation.
Which is why those Clearmoss and Planktos could just go ahead and do it, presumably.
Yes, yeah. I mean, it was sort of open slather, and they certainly weren't too unhappy, I think, about that situation. So there has been some progress in developing policy with groups like the London Convention, who oversee the dispersal of pollutants and dumping of material in the ocean. And so one of the things we wanted to do with this report on ocean fertilization was to pitch it at the sort of level of policymakers, so that they could have a look at it, at the pros and cons. They could hopefully pick up some of the nuances and some of the complexities that I just mentioned, that it's not just a simple matter of you add this and you suck up the carbon and you get a bunch of carbon credits. So we tried to, in sort of stepwise fashion, take them through what the issues are, what the confounding facts are, what some of the evidence is to date, what some of the speed bumps and problems are, because the issue at the minute is that no one has actually gone ahead and done a sufficiently large experiment over a sufficiently long period of time to know for sure what the outcome will be. So those are always issues that concern policymakers who like things to be cut and dried and or sort of demarcated as much as possible.
Can any of this stuff be modelled on a small scale in a lake or in a pool or anything like that?
Certainly, and there have been whole lake studies. They're very attractive. They're used by our sort of freshwater colleagues. You might have 4 little lakes, and you'll modify them all in slightly different ways by giving them different treatments and so forth. The problem with the ocean is that you have this problem of ocean circulation. And to give you some idea about ocean circulation, people who work in it, they use a unit called a sperdrup. And a sperdrup sort of is, I think it's about a million cubic meters of water per second.
Yeah.
Which, it's quite hard to get your head around.
Yeah.
And so with this sort of tyranny of ocean circulation, you can put something or modify something in one part of the ocean and it doesn't go away. Its residence time in the ocean with circulation might be over 1,000 years. So you have to be careful what way you manipulate things. And some of the mathematical modeling experiments where they have tracers that they can put into a model which do a good job and have been carefully tested to sort of mimic the different aspects of ocean circulation, they've been showing some interesting results because, of course, they can play all sorts of thought experiments. They can say, let's fertilize this part of the ocean for 1,000 years. Let's see what happens. Let's fertilize every other year. Let's fertilize once every 10 years. Does it make any difference? And they can play games about how potentially sensitive the system might be. And one of the interesting things they've found is that if we went, say, down to the Southern Ocean south of New Zealand and we added iron and sucked up a lot of these plant nutrients and sucked up some of this carbon dioxide, there are actually interesting far-field effects. And by far-field, I mean what happens in the Southern Ocean could impact the productivity of a fishery in the North Atlantic.
Wow.
It's a bit like the old notion of robbing Peter to pay Paul. Some of those nutrients, although they're not taken up in the Southern Ocean, will eventually be taken up as they're moved by ocean currents. And so you get into this interesting debate about who's actually responsible. For example, some fishery crashes in the North Atlantic. The Basques get a bit upset. The Portuguese and Spaniards go on the rampage, and it's actually because the Acme Iron Fertilization Company in the Southern Ocean has just made a bunch of money on carbon credits.
And of course also you've got migrating fish like sharks and whales and whatnot that might pass through areas that have been treated and then not treated, and that might possibly have some effect as well, I'd imagine.
Sure, no, it raises a whole raft of different possibilities. It brings a sort of a geopolitical, a moral, and an ethical sort of dimension to this discussion, and that's something that's taken us aback a little bit. It's certainly very interesting. It's certainly something that we have to become more involved and engaged with. And again, because this is a summary for policymakers with this report that we've just been discussing, we've tried to touch on some of those issues.
One of the sort of the other side of the climate coin on this is that if you're stimulating a lot of phytoplankton growth, and you said this at the very beginning, you're increasing the biomass in that part of the ocean, so you could be feeding the food chain as such. And I know that one of the sort of co-benefits of this might be fishery enhancement. Is there any sort of evidence that might be effective? We know the oceans are being overfished, and there are all sorts of alarming reports about when we might be forced to eat jellyfish and chips rather than lemon, sole and chips or whatever. But does the other side, is there a possibility that by fertilizing the ocean we could improve our fisheries and perhaps buy some time?
Well, there's a couple of things. One is that a number of people have actually purported to be able to do both. Is that you can either, in terms of increasing your stocks, if you want to sequester them, then you have to sequester as much of them as you can. If you want to boost productivity, then you don't want to sequester them. You want them to stay, for example, in the upper ocean to support a pelagic fishery. One guy in Australia is sort of claiming that he can actually do both, which is pretty amazing feat. The carbon has to either, as I say, move up the food web, which involves a lot of it being broken down and remineralized, and carbon dioxide being released, and then you will enhance your fishery, but you'll do nothing for climate change or mitigation of it per se. Or if you sink it out to depth, then you may be able to increase carbon sequestration, but you won't actually enhance the fishery per se. So it might be possible to do some sort of surface ocean fertilization, but again, the sort of regions we're talking about, for example, the Southern Ocean, which because of the vagaries of ocean circulation is the most efficient place to try and sequester carbon. But again, in terms of fisheries down there, you're talking about maybe enhancing a toothfish fishery, whereas there'd be other parts of the ocean, if you wanted to try and enhance productivity, you might, and then boost the fishery, you might tend to do that there. And again,
Okay.
it's not quite that simple, because again, we know in sort of coastal waters that if you start to push in too many nutrients, you may increase stocks, but you may end up with one of these so-called harmful algal blooms. So it's not just always a case of adding more nutrients will give you the desired outcome. There are other subtleties and other complexities.
I know I put in a beautiful NASA shot of a phytoplankton bloom off the Chatham Island a couple of months ago, I guess, and that was a massive bloom of coccolithophores, and they said it was due to the fact that it was a mixturing of cold, nutrient-rich but iron-poor waters with warmer waters that had iron in, and this happened every spring off the coast of New Zealand. I just thought it was a fascinating kind of insight into what was going on a large scale.
Yes, I mean, with some of our research at NIWA for the last 10 or so years, we've been working hard to better understand what the drivers are to the system. And if you understand what the drivers are, how they interact with ocean currents, then you get a much better understanding of what's going on. And if things start to change, for example, due to El Nino activity, or because of climate change, then you've got a better idea of how to interpret the new data coming in from a satellite, for example. So
yeah. So where is your work taking you at the moment? What's the research that's keeping you busy?
A number of things. One is that we're interested, as I mentioned earlier in the broadcast, in finding out a bit more about where the various sources of iron are in the ocean. Do they take sort of place globally, or are they just regionally significant? Do they happen at certain times of the year? So from work we've been doing in the Southern Ocean now, we've identified probably 10 different iron supply mechanisms. So it's trying to tease apart their individual effect, and then how they contribute to sort of a collective stimulation of productivity there. And the other thing I've just been doing today, actually, I've been Skyping into a meeting run by the IGBP, the International Geosphere Biosphere Program. They're actually having a 3-day workshop on the effect of geoengineering on ecosystems.
Cool. Is there a particular place on the web, a site that people can follow the progress?
I think they had a number of podcasts yesterday. I'd have to double check. I can send you that email on.
But I mean, for you and your work, is there a particular destination people can go to keep up with the play?
They can either look on the NIWA website, where there's some information about me, or also on the University of Otago Department of Chemistry website, because I have a cross appointment between the university and the CRI.
Okay, well I'll make sure that those sites are in the show notes, Philip. So yeah, that's fascinating. When you do field work, I mean, you must have to have a very strong stomach if you're out there in the middle of the Southern Ocean. Yeah,
it does. It can be a little bit wearing. You get bumped and bashed and bruised, and you don't see land for maybe 5 or 6 weeks. So there's a downside, but there also is an interesting sort of upside, in that you sort of get very attuned to the different seascapes and how it changes, even though it's 40 shades of grey. For example, down in the Southern Ocean, you do sort of get your eye in, and you notice changes in the pattern of the swells, winds, and so forth. So yeah.
That's fascinating, Philip. Thank you very much. So I'll put some notes in the show. I'll link to the IGBP report on ocean fertilization so that all of our listeners and viewers will get a chance to read what you've been working on. And thank you very much for taking the time to explain what's obviously a complex but fascinating topic. Thank you.
Cheers, Philip.
Oh, pleasure. Thanks, guys.
Here we go. That's Dr. Philip Boyd, phytoplankton ecologist. Alrighty, let's get into the climate skeptics section with John Cook from skepticalscience.com. Come on in, John. How you doing?
G'day, Glenn. I'm good, thanks, mate.
Hi, John. It's a bit more wet and windy weather for Queensland on the way.
Yeah, we don't seem to catch a break here. We're just recovering from the floods, and now it's happening all over again.
Yeah. So this cyclone Yasi is it looks this Category 5 hitting somewhere between Cairns and Townsville. Sounds horrifying.
Yeah, I had a look at the map of the cyclone path yesterday, and it was a Category 3 then. And then this morning I had another look, and it's already been upgraded to Category 5.
Yeah.
And the path seems to be going straight for Innisfail, or just south of Innisfail, the last I looked at it. And that was the town that got hit by a cyclone a couple of years ago. So, yeah, they're a very unlucky town.
I heard it, a commentator yesterday say that this is quite exciting, but I'm not sure. I mean, who is it exciting for? Do you think?
I think it's exciting for TV commentators because they've got something interesting to talk about. At the moment, I think about 30,000 people have been evacuated out of the Cairns Innisfail area, but I think there also seems to be this influx of morning show hosts because on TV this morning they were all in there talking about the cyclone.
Yeah, and it was actually Queensland where the subject of our chat today actually ended up in this documentary that I've just finished watching called a BBC documentary called Meet the Climate Skeptics. Christopher Monckton, he visited Queensland, but he wasn't visiting Queensland this week, John.
No, well, it was a bit of a cyclone when he did tour through Australia, but a different kind of media storm, I guess.
You've done
a lot of hot air.
Yeah. You've done you've basically written up a whole section on the Skeptical Science website, debunking Christopher Monckton, which can't be that hard these days.
Well, he publishes a lot of stuff, and that was part of the motivation for doing it. He's just this amazingly prolific, skeptic who's always publishing these long, endless articles with just all this series of misinformation.
But when you say published, because the documentary that I've just watched said that he's never published anything for peer review. So when you say published, what do you mean?
Well, there's the internet. Anyone can throw something on the internet. But one of the biggest climate sites. What's up with that? They regularly, give him a forum to publish all his stuff. And
it's been said that the only form of peer review that Monckton's articles get is when he reads his own work. Let's go back to basics. Who is Lord Christopher Monckton, John?
Well, he's an English lord, although I'm not exactly sure what the status on that is.
I think he's a viscount.
Yeah, so the viscount of Benchley or somewhere. And
I should say Brenchley is a charming little village in Kent that used to have really good pubs when I was a student. It may well have changed since.
And so his background is in journalism and in politics, but lately he's a self-appointed climate expert. And so, so what got us interested in this and began this whole Monckton myths was just a couple of weeks ago he published this article on What's Up With That, where he responded to all these to an article by Mike Sticchetti in the Australian, where Mike was just talking about the dangers and consequences of global warming. And what Monckton did was write a whole series of about 20 odd points just supposedly countering Mike's article. And what it was just a series of misinformation. At every point had something incorrect in it. And so at Skeptical Science, we have this team of debunkers who, just a whole team of writers who examine the science. And we looked at Monckton's article and thought, how could we respond to this? It's there's this phrase called the Gish Gallop, which is where people can, when they get into a debate, what they do is they just rattle off a really long series of misinformation, and it's almost impossible to respond to, because to go through each point would take hours.
So it takes Monckton sort of 30 seconds to say something which is at the very least debatable, but it might take you 30 minutes to explain why it's irrelevant or rubbish or both.
Yeah, and that's the whole dilemma, that it takes so much work. You can just make something up, and it would take hours to prepare it and then to explain it in detail. But
so when you went through all his work, I think you found that there was a bit of a pattern, that he was repeating himself.
Yeah, so we started with that one article and we started examining all the science in it, but then we started looking back through all of Monckton's work, and because he's so prolific, he just writes so much content, and not just like small articles or blog posts, but these long essays. And what we found was throughout all these essays, it's just the same misinformation appearing over and over and over again. So, so there's this saying by Winston Churchill that a lie can get halfway across the world before the truth has a chance to put its pants on. So, so that's a dilemma in countering misinformation. But in the case of Monckton, the lie might get halfway across the world, but by the time it gets around to the start, he just sends it back on its way again. And so that's what inspired this resource. Is we thought by the time it starts its second journey around the world, we can at least have the truth all dressed up and ready for action. And
so what are some of the key sort of mistakes that Monckton makes, or repeatedly makes? The deliberate misrepresentations, shall we call them?
Yeah, so by having this database of all of his articles and then which arguments he uses, that enabled us to just I guess have like a top 10 list, like all of his most popular arguments that he used the most. And the number one was that climate sensitivity is low, which is another way of saying that the warming that CO2 causes will be suppressed by negative feedbacks. And to back this up, he cites the work of Richard Lindzen, who has done research suggesting that there's negative feedbacks that cancel out global warming. But
for those just watching, sorry to interrupt the live video stream there, we put a picture of Monckton up there just so you can get an idea of the man himself. There's a couple of pictures up there, but you decide which one is the closest to reality. Sorry to interrupt you, John. Go carry on.
That's not very kind, Glenn, that second photo. So what I found, like examining this question of climate sensitivity, is what Monckton does is just give you a fraction of the picture. He just picks that one study that backs up his position and ignores all the evidence, all the other estimates of climate sensitivity that find positive feedbacks that amplify our warming. So
I've even heard him describe himself as one of the few people who's done real work on this issue of climate sensitivity on the basis that he was invited to write something for a newsletter of the American Physical Association, I think. I've called this one of his sort of great lies, because he's quite happy to go onto TV and pretend to be an absolute expert in this area.
But he's not even a climate scientist, though, is he?
No, absolutely not.
He's done medical research, as far as I understand.
He was a junior. I mean, he was in his sort of, I guess, late 20s when he started working in Margaret Thatcher's policy unit in Downing Street in London, and he was one of her sort of private private policy thinkers.
Yeah.
But he was a junior in that department. She didn't even mention him in her autobiography.
Poor old Monckton. So, John, you're saying so one of his main arguments surrounds climate sensitivity. Now, isn't that quite common across the board with climate skeptics? They're not really debating the fact that CO2 causes warming. It's by how much is what they're debating.
Well, that's what a lot of them say. In fact, somebody criticised some of my work this week, saying that when I publish evidence that global warming is happening, they're not actually disputing that. Although in the next paragraph he then said, well, global warming stopped in 1995 or something. So they'll often say, oh, we don't dispute that, but they'll still cite the latest snowstorm to disprove global warming.
So after this issue of low climate sensitivity, what's the next most popular Monckton mistake?
Well, the next one is sea level rise. And he likes to quote Niels Morner, who is a scientist who has said that it's physically impossible for sea levels to rise very much more than their current levels. And again, he's doing the same thing as he does with climate sensitivity. He's just picking this one quote or this one scientist and ignoring all the evidence that says otherwise. So like this graph I'm showing at the moment, this shows sea level rise, like a prediction of sea level rise based on, well, it's just using one technique, which is to compare past sea level rise with past temperature change. And we find that the two match. Whenever it gets warmer, sea levels rise goes up. So they'd use that to predict how sea level rise would change in the future. But there are a whole range of ways of predicting what sea level is going to do in the future. There's examining glacier dynamics in Greenland and Antarctica, and that gets essentially the same result as this first graph, which is that sea level is going to rise between 80 centimeters to 2 meters by 2100. And there are other methods as well. We see that Greenland is losing ice at an accelerating rate at the moment, nearly 300 billion tons per year of ice. And when we look at sea level rise in the past, the last time that global temperatures were about 1 to 2 meters warmer than current, sea levels were about 6 meters higher. So there's a whole range of evidence that tell us that sea level not only can get higher than now, but we expect it to as it gets warmer.
I encourage anyone to go and if you can, try and see this BBC documentary, Meet the Climate Skeptics. Monckton is kind of the central figure in this hour-long documentary. But there's a quite an absurd scene before a very weird scene. It was just weird after absurd scene, but where he's reciting the periodic table. I think that was to show off his knowledge of science. In fact, he was singing the periodic table. I think it was something from childhood. But there's this weird scene where he's pouring acid on rocks in the outback, and that was meant to prove something. And I'm not sure the documentary maker knew what he was on about either. But he used this so-called science of pouring acid on rocks. He used that in front of the Congress in the States when he was presenting evidence against climate change. Do you have any idea what he was on about there with rocks and acid?
Yeah, I think I can fill that one in because during his tour of Australia this time last year, he came out with a debating point. He debated and lost a debate to Tim Lambert of the Deltoid blog. And he used this, the rocks in the outback, to demonstrate what he thought was a telling point that CO2 could have no really damaging effect on the climate because at this particular period, several hundreds of millions of years ago, CO2 levels in the atmosphere were very, very high indeed. So you're talking about thousands, if not tens of thousands of parts per million of CO2. And at the time, there was ice. There were glaciers almost to the tropics. And so he was using this to say, well, look, if you can have ice at the tropics and CO2 at this sort of level, then the two, CO2 can have no role in global temperature.
Right.
Unfortunately, what he didn't explain was that the buildup of CO2 was what actually ended what was called a snowball Earth phase, with ice stretching from pole towards the equators, and that the buildup of CO2 that occurred was effectively what saved the planet from becoming a permanent snowball. John, how do you expect people to use this?
The main thing, I guess the main sort of purpose of it is because Monckton is always bringing out all these new articles, but he's just rehashing his old material. It's a bit it's not really practical to reinvent the wheel every time Monckton publishes a new article and have to construct a whole debunking of every point. So what I'm doing with this is whenever a new article gets added, we just list it on our Monckton Myths page, and also we just automatically list all of the different arguments that he uses in it, which we've already written detailed rebuttals to. So whenever you encounter a new article by Monckton, just go to this page. The article should either already be listed, or if it isn't, let us know and we'll add it, and it will give you all the rebuttals.
Have you got a Latin translator in there to check his verbiage?
No, I probably wouldn't go up against him on Latin. He'd probably outdo me there.
It's worth pointing out that his degree at Cambridge was actually classics, so he is certainly probably, and I'm perfectly certain, very, very skilled as a classical scholar.
But has a thorough misunderstanding of climate science by the looks of things.
Well, yeah, exactly. I mean, I suspect it's worth perhaps pointing out that he's the deputy leader of the UK Independence Party, which you might charitably describe as somewhat to the right of the Conservative Party in Britain. I came across a very interesting description of the sorts of arguments that Monckton advances, and indeed so many of the prominent skeptics. It was described as denialist chum, and chum being the sort of stuff you throw off the back of a boat in the ocean when you're hoping to attract sharks or to get fish feeding before you dangle your hook in front of them. And the implication being that what Monckton is actually doing is just throwing out arguments which will play to his audience, and his audience are the people who want to believe that climate change isn't real. So in effect, he's not making real scientific arguments. He's pretending to do that because it looks good, but what he's actually doing is feeding a PR campaign which is designed to, this is my opinion, which is designed to make it difficult for politicians to act, and so ultimately it's a political act.
Which is what he said in front of Congress, didn't he? He said he wanted them not to act, so not to go either way, just do nothing, was what he was saying.
I think the direct quote is we need to have the courage to do nothing.
That's it, yeah.
But what he means by nothing is the courage to continue throwing 30 billion tons of CO2 into the atmosphere.
Yeah,
and the courage to continue subsidizing fossil fuels and the companies that extract and sell them. Yeah, that doesn't count as nothing in my book, but there we are.
Well, those myths debunked up at skepticalscience.com. I can give you the whole full address of that. Actually, it's /Monckton_myths.htm, or just follow the links from the front page. John, I think you're doing a great job over there.
Yeah, thanks for having me.
Yeah,
John, I hope that I sincerely hope that by the time the show comes out, Cyclone Yasi will have hit Queensland, and I hope for all of your sakes that it proves to be a bit of a damp squib and not the sort of monster storm that we can currently see. So good luck to everybody in Queensland.
Yeah, thanks. I guess we'll know after tonight.
Thanks, John. And we'll be recording again in a couple of weeks. Have you got any ideas? I think we're going to talk about ice, aren't we?
Yes, that's right. Yeah, lots of different skeptic arguments to do with ice melt and glacier melt. So plenty to talk about.
Excellent. All right, John. Well, look, thanks very much, mate, and good luck, and we'll speak to you soon.
cheers, John.
See ya.
So once again, always a pleasure, of course, to have John on the show. And boy, oh boy, that cyclone. That by the time this show comes out, I guess it'll be sort of old news, and maybe even sort of in the thick of it, I suppose. But man, that thing is mammoth.
Absolutely, it goes back to one of the important things that we talked about when we were talking about the Queensland flooding with John a couple of shows ago, or in the last show, in fact. And that is the record sea surface temperatures of Australia.
Yeah.
That's a recipe for intense tropical cyclones. There's more heat to go into the storm, and therefore it becomes bigger. But yes, I hope that by the time everybody's listening to this, the cyclone will have passed without causing Queensland too much in the way of devastation.
Indeed. So I think it's a good time now to look at the many parts solutions. Now, can the humble Datsun be part of the solution, Gareth?
Yeah, absolutely, and we'll close on the humble Datsun.
Okay.
What I wanted to focus on today was electric vehicles, because one of the trends, it seems, for 2011 is that everybody and his wife is making electric vehicles. The first one that caught my eye was that Tesla, who created a really sleek little electric sports car a couple of years ago. It's become very fashionable and very successful. They've announced that they're going to produce a sports utility vehicle, an SUV, in other words, one of those big things, and it's going to be electric. It's going to be called the Model X, and they're going to unveil their designs for it at the later this year. So it's not the picture we currently have on screen, is it? It will be a utility vehicle. It will be an SUV as we know it. Yeah, that's right. What the picture is actually, I think, their Model S, which is a large, sort of saloon car, basically, electric saloon car. No, the Model X is an SUV, and to me, that's actually the car I want. I want an electric vehicle that will take me up New Zealand ski roads. Yeah. So, and I actually think that electric vehicles are uniquely suited for four-wheel drives, because you can put effectively a motor in each wheel, and you can do all of your traction control and everything else in software. Okay. Or in the electronics. So for anyone who's got any sort of interest in these things, it really does begin to look as though the sort of momentum is building for electric cars from all sources. I've also heard, for instance, that Porsche are planning to do hybrids. So that's crossing a petrol engine with an electric motor and batteries, linking the two together. BMW are planning to do the same. Now, those will probably be a bit like the Lexus hybrids. They'll be aimed at the top end of the market and designed to do more to make cars go fast than to actually cut down a lot of carbon emissions, although hybrids will reduce petrol consumption. So it's all beginning to come. I think Mercedes-Benz is going to be doing something similar. So there's an awful lot happening in that whole area. I think we'll know it's definitely hit the mainstream when we see hybrid or electric vehicles screaming around Bathurst. Absolutely, and that's the next item. There is now a thing called the EV Cup, which is a series of races involving electric vehicles only, whizzing around Europe and Britain and so on. And at the EV Cup website, you can see the sorts of cars. What was that? That was my phone, my electric phone. Don't worry about that. I'll throw that away. I thought you were doing electric car noises. Like kids when they play with dinky toys. They go brum, brum, brum. Because when you think you've got something on silent, but it vibrates the desk. Anyway, yeah. Oh, well, never mind. So yes, that was interesting that you've got these electric vehicles being used in sports now. And I think that's cool too, because people who are into motor cars are not necessarily into them just because they run on petrol. They might think that the world's fastest cars run on fossil fuels, but in fact, electric motors have some unique attributes that make electric vehicles potentially great fun and high performance.
Okay.
And one of those things is that an electric motor has constant torque, when you have a petrol engine, you have to rev it a lot to get maximum power. Or when you've got an electric vehicle, that power is available the minute you put your foot on the accelerator. So I'll put a link on the site, and what you're seeing on screen at the moment is a thing called the White Zombie. And the White Zombie is a 1970s Datsun that has been kitted up with lead-acid batteries and an electric motor. And it's a dragster. And this thing is just amazing. Glenn's going to see if he can get us onto the section of this particular YouTube video where the cars take off, because this White Zombie leaves all the big petrol dragsters just smoking on the start line.
Yeah, absolutely. We're just seeing that now, and really that torque that you've just been talking about is extraordinary. I'd imagine what the G-forces are inside that Datsun.
Absolutely, and I mean this car at the time that they made this video was setting world records, which is I think it's fantastic. So it just shows that you don't have to be a petrol head to be into motorsports. You could be an electron head, perhaps.
Perhaps so.
So, I mean, I'm just saying that, one of the reasons I like to focus on electric vehicles is that, some of the solutions to reducing emissions, that, just doesn't have to be, all hair shirts and eating carrots and walking to work. It can actually be, there are fun things too. And I thought the White Zombie, somebody linked to that video on the very excellent Open Mind blog, and I was just blown away, riveted for 10 minutes. So well worth watching. You
can still have happiness in a low carbon world, I think is the message there, if speed is your happiness.
Absolutely.
Thanks very much, Gareth. That concludes another episode. Thanks very much to Dr. Philip Boyd for joining us, and John Cook over at Skeptical Science. Don't forget, there are many ways to enjoy the show in video on YouTube with the links at hottopic.co.nz, also via iTunes or whatever your podcast subscription method is, or even just download the audio file as well. So two ways, in audio or video. And don't forget that the website will be coming very, very soon, because I have been tinkering away, finally got into it for this year. Theclimateshow.com, it will be up and available once more. And of course, thanks very much to the Bads for the theme to the show as well. Great theme. Drop in the ocean.
Very catchy.
There you go.
Hey, and so we're recording again in 2 weeks. We've got some plans for the next show. I'm hoping that we'll get a scientist called Jason Box, Professor Jason Box, who's one of the leading experts on the Greenland ice sheet. And we're hoping to catch Jason before he leaves for the very beginning of the field season on Greenland. So it's going to be a fascinating chat.
Really look forward to that. Also, don't forget to follow the progress, and we'll tell you who's coming up on the show as well over at facebook.com/The Climate Show and twitter.com/The Climate Show. You can find me at twitter.com/Radio Whammo or glennwilliams.co.nz. Of course, Gareth, you're at hot-topic.co.nz, and on Twitter
it's Hot Topic NZ with no hyphen. So anyway, that's been a good show. Thanks very much, Glenn.
Yeah.
And thanks to everybody out there, and give us feedback. We need feedback. More feedback, please.
Indeed.
Just don't tell me I need to lose weight.
Likewise. Anyway, we'll see you next time.
What good is a drop in